Hi, I'm Avery. I'm co-founder and CTO at Aptos. These lights are extremely bright, so don't mind me if I start looking all around the place. It's great to meet all of you folks here at Denver and Interop specifically. And I'm definitely excited about the multi-chain future here, and also what we've been doing at Aptos to help bring that about. So just a bit of background on us. My history is that I was a PhD in high-performance computing. I worked at places like Sandia and Los Alamos on some of the world's largest supercomputers, on solving problems like protein folding and matrix factorization, including things like safe nuclear simulation as well. I made my way to Meta in 2011 and worked there for 10 years in data infrastructure. And in 2018, there's a pretty ambitious initiative started off, initially called Libra. The idea was, how do you kind of build decentralized access to financial assets around the world? And kudos to Meta for actually jumpstarting that project and bring together a whole bunch of different experts across different disciplines: systems, high-performance computing, programming languages, cryptography, and many others, and then helping us to basically seed what we thought was the next set of generation of ideas in this space. So when we started with this thesis in 2018, we thought about what are the problems we want to solve? How do we get billions of people to use infrastructure such as blockchain and Web3? And we came kind of down to these three different areas that we felt were the most important to focus on. First off is that your developer experience should be intuitive. It should be easy, as easy as coding in, say, Java or Python or Rust, but with the safety and security that you would expect from a high-assurance asset like a smart contract. We thought about instant would be important. We've seen how latency and user experiences can play a big part in terms of the adoption, in terms of people wanting to use it on a daily basis. And of course, things have to be very expensive. People are already used to very low-cost cloud computing infrastructure that exists in the world today, with services such as AWS, GCP, and Azure. So with these things in mind in 2018, we thought through a set of core design decisions that we thought would help us on our way. First off, we designed everything from scratch, which is the typical Facebook way of doing things. There was a new programming language being built. There was new blockchain infrastructure being built. And many of those lessons from DM, in that case, were brought into Aptos. It was something we forked off of in the past. Upgradability and configurability were super important to us. And the reason is because this space is so nascent and so early. Even all the blockchains put together today can't do what a single MySQL server can do in terms of throughput and latency. And it takes hundreds of thousands, if not millions, of those servers to power applications such as Facebook or Gmail or Search across the world. And so as an industry, we have so far to go in terms of before we kind of reach the full potential of our technology. And so we wanted to make sure that upgradability was first up in mind. Alongside of my background in high-performance computing, another thought is, how do you take advantage of all the resources available to you for doing transaction processing? And that can include multiple CPUs, more memory, more disk space to you, and also in cluster-based technology. And so taking on a new design approach in terms of something that would be pipeline and modular in order to exploit all the resources of the machines, as well as networking components and others, was something that we thought was really important. Along the way, we thought about learning lessons from what previous databases have done. Decentralized databases, another fancy word for blockchains. The key difference is that the first word is decentralized. Yet there are still some important things we can learn from those technologies. Things like optimistic concurrency control, which is a key important feature for how we think about things like block TSTM and parallel execution without having to impede the developer experience. And finally, as I mentioned, we have a long way to go in terms of the infrastructure scalability of our software stack. And so we're thinking about different ways in terms of we scale, both horizontally and vertically. So starting off with an intuitive experience. Some simple things here are like, how do you decouple public keys from addresses? That's a simple idea, but now allows you to do things like key rotation. So in case you don't have a situation where you think your key might be compromised, you can actually just rotate whenever you feel like that's an issue. We provide things like crypto agility, where we support EDDSA signature schemes. We also support BLS, multi-sig, and a whole host of other things that are very flexible and customizable to the user experience. And finally, we support also smart contract based recovery. So if you can imagine a world where you've lost access to your key, you could have a smart contract which, for instance, delegates the responsibility of key rotation to a custodian that you trust, whether it's a bank, whether it's a well-trusted internet provider. And you can have interesting models where things are like, I haven't transacted on chain for 6 months, and now I'm allowing that entity to actually do a key rotation on my behalf if I can prove my identity to them. But while I keep transacting periodically, they don't have the access to do that. And so it kind of provides these interesting semi-custodial hybrid models, which are not available in all networks today. The second thing we think that's really important is about how do we produce human-readable transaction outcomes. So in Aptos, whenever you're about to execute a transaction, the first thing that happens is that you will send that transaction typically from your wallet to a full node, and it happens automatically. By doing this, you can simulate the results of that transaction, and I have an example here in the coin and buying a broad bear, in terms of what the fees will be, the payloads, the write sets, the events that are going to be produced. All these things provide you very clear, strong clarity in terms of what the transaction is doing prior to signing it, not afterwards. Another area is thing we think about is transaction viability. So once you sign a transaction, how long is it good for? How can you prove that transaction is not going to be used in the future or hold you hostage over what you've done in the past? And so things like sequence numbers as well as expiration times that can be set by the transaction allow that kind of guarantee that if I haven't seen the transaction committed to the chain before the sequence number has been passed or before the expiration time has been hit, I can guarantee that transaction will never be committed. And that's something that's really nice and makes you feel warm and fuzzy as a user. The final thing is many chains do offer like-kind proofs. We do too as well. One difference is that with a high-performance clock in the Aptos blockchain, we think that provides a very nice way to provide strong auditability of things that happen on the network. So you can know with sub-second granularity with respect to the commit times of different transactions and when they're executed. And this is we think is very helpful for users. Move is obviously something that we're really excited about. It was designed from scratch back at Meta as a smart contracts language. It's got all the things you would expect. It's deterministic, it's metered, and it also provides things around data being stored under user accounts, which is very nice. So thinking about the way some blockchains will keep that data in contracts makes it very hard for users to be able to access that data in different contracts going forward. And by keeping that within a contract, within the user account itself, it's easier for contracts to operate with that data in a much more seamless way. The other thing that's great about Move is it provides support for things like resource conservation and safety by having different kinds of attributes around what is allowed to be duplicated, what's allowed to be copied, what's allowed to be dropped, and when those operations can occur. That provides just a simpler way you can't shoot yourself in the foot so easily. When you think about operating with things like coins, you don't want to treat them as integers, for instance. You don't want to actually multiply them or divide them or do things that just are not natural for how you think about money and currency in that sense. And Move is still, a new language. It's been around for 4 years, which is great. But we think that there's a huge amount of necessity for improving and evolving this language going forward. And so in 2023, we're taking this, to the next dimension in terms of adding new features like higher or lower inline functions. We have this concept of resource groups, which is really exciting. The idea is that you have structures, and as a programmer, you can go ahead and figure out how do you want to organize these structures into storage space to optimize gas costs as well as execution times for your benefit for the application. And then our last thing we're working on that will come out this half is around Move objects. How do you kind of compose these different structures in a way where you can create kind of safe references between different things and create things like composable NFTs and dynamic NFTs in a very natural and scalable way. And I think I talked to this a little bit more, but upgradability is something that's really, really core to us. And we are very excited to say that our 1.2 release actually is just kind of gone live this month. In February, it comes with a whole host of new features, including new Move types, new 256. It comes with new crypto primitives and many, many more things. This is just 4 months after our launch back in October. We also were, to demonstrate this thesis of upgradability inside the kind of previous mainnets we had within Diem. And we can do this in a way which leverages on-chain governance, which is really neat. So a lot of blockchains will use kind of block heights or certain times in which they make the upgrades go live, which is kind of tried and true practice. But it's very hard to predict when you set these times in advance. If you're too early, you have to make sure the network has already upgraded past that point, because or else you're going to be in probably a fork. If you're too late, it's going to just take too long for the upgrade to happen. And so by leveraging on-chain governance, token holders can vote in terms of whether they want those upgrades to go live, and they can kind of come live instantly as soon as thresholds are hit, which is really cool. A key part of our design is really about this pipeline modularity, and I want to spend a little bit of time on this. We've broken the processing stages into 5 different unique stages. Each of them can operate independently. Each of them is parallelizable. The first phase we call continuous transaction dissemination. Each validator will send blocks of transactions to other validators and produce what's called a proof of availability. This proof kind of ensures that these transactions will not be lost to the system. It's a stateful process. Second phase that happens is what we call block metadata ordering. So validators will agree on an ordering of these blocks of transactions, but you do not just set the transactions with them, nor you do execution. And by decoupling consensus essentially from these two operations, both the dissemination and the execution, consensus is not a bottleneck. And it's extremely fast, basically sub-second. Just 2 round trips and things are committed. Next phase is what we call parallel execution. So once you kind of have this list of kind of committed blocks to your storage, you can execute those transactions. And then the interesting thing here is that the order of transactions that came in can be reordered as long as it's done deterministically. This allows us to optimize for as much parallelism as possible, as well as take advantage of other properties where you can, for instance, maybe even thwart some of the different MEV attempts out there in practice. And this is where block STM comes into the picture. The fourth stage is around batch storage. As you know, writing like 1 byte at a time to storage is extremely inefficient and very slow. If you write hundreds of bytes at the same shot, you get much better throughput, fewer seeks, all those fun things. And so we take advantage of that in our pipeline system as well. So as blocks are being executed, the results are being stored in memory and then synced to disk in one large operation. The final phase is what we call state-proof certification. And this is very decoupled from the process of execution, where nodes will eventually agree on the output of the execution results, and these can be used for light client proofs in the future. But the great thing about this is that all these stages operate independently, and they're not blocked by each other. This allows us to get full utilization of the resources in every machine, or even clusters of machine if we want to scale out that way. Talking about block DSM a little bit, it's one of the key technologies to our system. So parallelism and how we express parallelism has been always an interesting construct in the blockchain world. Also, very interesting in the HPC world, we had things like MPI, and then we went to things like Hadoop and bulk synchronous processing models. That paradigm became very simplified and accessible for developers, but maybe had more constraints in terms of controls and what people could do with them. And so, in this case, we've taken the approach of we want to make easy things easy and hard things possible. Block STM allows developers to kind of program as naturally as they would with sequential models. But whenever there's parallelism, they get automatically extracted on behalf of the programmer. And this is very valuable because it's simpler to program. But the other thing is that sometimes when your programs are there, you can't know a priori exactly what the dependencies will be. And so in those cases, you have to kind of split transactions up into smaller sub-transactions, which makes for difficult recovery, very hard composability, and just a nightmare from a developer and user perspective. Block STM allows you to kind of maintain that parallelism, even in those cases, because it will extract it automatically on your behalf. And in terms of pessimistic parallelism, we can also support that as well. If you wanted to specify for some transactions those dependencies up front, those can be annotated, those will be annotated in the future and supported alongside this model. And they're very complementary, which is very nice. The great thing about this technique is it scales really well with respect to the amount of contention and resources available in the system. And that's kind of what our experimental results show. I would love to talk about the Aptos ecosystem a bit. We've been live since October, essentially, and we were very pleased to see that so many projects have started to build alongside Aptos with us over time. And so, within those first 4 months, we've seen more than 100 projects launched, 200 plus building in this place, thousands of NFT creators and collections. We were very excited about the fact that the Aptos repo and the Move repo has hundreds of developers and contributors to it already. And that's something that we don't take for granted. We think it's a very important part of how decentralization works. Having an open source community, having lots of developers contributing towards this and helping guide it in different directions. That makes sense. And we're also excited about many of the mainstream partners that are partnering alongside us because one of the things that we need in Web3 is this adoption of applications and usage, right? We haven't had that case yet where there's a killer app where you have a Facebook or you have a Snapchat or TikTok where you have daily hundreds of millions of daily active users, and we're waiting for that. And so, as we see these partners in the list, we're very excited about 4 different areas. One is going to be gaming, another is social, finance, and then kind of media, entertainment, and sports. And so each of these kind of groups is represented well, I think, from the set of parties here. And we're here to talk about timelines, so let's definitely get to that. So in 2022, there are a lot of things that happened for us. We formed the company officially kind of in January-ish, or December, I guess, of the previous year officially. We kind of announced the formation of the company in February, and 1 month later, we had launched our first DevNet. Our thesis was to understand exactly what people thought about Move and thought about the Aptos blockchain. And we're really delighted to see that people started to develop things and build smart contracts, as well as to onboard full nodes to the system. I think within a couple of weeks, we had more than 18,000 nodes connected to the blockchain, which would make it one of the largest networks available at that time. And then after that, we saw in May, we started to launch our first incentivized testnet. We wanted to get started with how we prepare for mainnet launch. That was with more than 100 nodes. In July, we started a second incentivized testnet. That was with staking properties, 200 plus nodes. And then August, we started our final incentivized testnet. And that was to support, again, our key features of governance and updates going forward. And then finally, in October, we made our launch, and we were very excited about that. some of us, during that time had thought about, whether we should, wait a little bit longer, go faster. And it was really our developer community that kind of inspired us to move as quickly as possible here, because we'd seen them building alongside with us, and we were really excited by the momentum. We wanted them to be able to launch their products. So within 1 week of launch, over 30 products had launched on the Aptos blockchain, and over, again, 100 plus today. So in February, we haven't this year we haven't been bored or idle. We launched our first major upgrade of the network. That's 1.2. It's going live. It's been live basically already since late February. And we have a host of number of things coming up for the rest of the year. So the first thing I'd say is that on the developer side, we're super excited about things like move objects, as well as resource groups coming live very soon. They'll come in the first half of the year. We also put out a blog post very recently about our path to lowering gas fees. And there's a number of different efforts we have in that space. First of all, we have building different gas-efficient data structures that work well with our model. The second thing we're doing is separating out how storage and execution costs work together. So the idea is that execution costs are very transient, storage costs are kind of long-lived and more permanent. And how do we make sure that when the network is not heavily utilized and there's definitely sufficient capacity, that the execution cost is basically free until the point at which you hit the kind of throughput limits, which are very high. We also are bringing in terms of new features, which is storage refunds and billing accounts. This will allow the ability for developers to take advantage of these new features in ways that can provide users with a better experience. So for instance, if you're building a DEX or you're building an NFT marketplace, you can have things like gasless transaction fees because there will be another party paying it on your behalf. And also if you're building a DEX and you're putting out limit orders or things like that are temporal in nature, once those orders are done, you can kind of clean those up and kind of recoup the storage fees, especially if they've been only there for short periods of time. We think that that's going to be really, really interesting, and we're excited to see what our partners are going to do with that feature. We also have a Quorum Store coming out in the first half of the year. Quorum Store is interesting technology which takes full advantage of the data dissemination techniques I mentioned earlier and the proof of availability. What we've seen in practice is that for situations where bandwidth becomes constrained, especially, there can be anywhere from 2 to 5x gains in terms of transaction throughput, and even better latency as well. You should also expect to see more advanced cryptography, developer tooling, and also we'll put out prototypes around sharding developments going forward in the future. The other thing I want to note is that we feel in this industry we'd love to see more openness and transparency around performance evaluation and benchmarks. Our plan is to start to publish benchmarks that are going to be some simple things in the beginning, account creation, how you think about NFT generation, P2P transfers, things that are very repeatable though, and things that other chains can also do. We will intend to launch these experiments in a way that supports people understand how the network will perform for your different use cases, and also in repeatable experiments. Something you can set up yourself on a cluster and also run the same things and verify independently. We're just running out of time, so I just want to run through this really quickly. We would love to have the community participate in what we call Aptos improvement protocols. Those are basically analogs to what Ethereum does. And we've already seen several community proposals that we're really excited about, including things like delegation and also other improvements to the object protocol from many others in the space, and we're excited. You can also add yourself to the list of ecosystem projects if you're building in the space, or also check out what's going on in Aptos. And there's a whole bunch of just handles for Twitter and developers and all that fun stuff. And with that, I think I'm almost perfectly on time. So I just want to thank you very much for taking the time to listen to me. And we're really excited about what's going on with Interop here and how we can be a part of the multi-chain future. So thank you.